Hi, David Can here with a question from topic 11.2. We're looking at rectifiers. You may notice this is not an IB question. The reason for that is that rectifier questions, as far as I know, do not exist in any past paper. So I've had to make my own. Hopefully it's effective. Alright, so what is a rectifier? A rectifier is a circuit designed to take an AC wave and transform it to a DC wave, direct current wave. Basically, the original signal alternates positive and negative voltage, positive and negative current, back and forth, back and forth. And we want the wave that is received by the load, so the load here, or the load here, to be in one direction only. And that could be a constant current and a constant voltage, or it could be a varying voltage that just doesn't reverse, a varying current that never goes backwards. The first question is, which rectifier is the full wave rectifier? It's going to be rectifier 1, and here's why. Both rectifiers are made of diodes, and diodes only allow current in their proper direction. So this circuit, rectifier 2, is going to allow current when it's flowing in a clockwise direction, but the diode will block the current if it attempts to flow in a counterclockwise direction, so nothing will happen half of the time. A full wave rectifier, though, uses both halves of the AC wave, the positive and the negative half. So you can see a little diagram of it here. Whenever the wave is negative, this circuit will just ignore it and won't use it, so that would be a half wave rectifier. This full wave rectifier, and we'll explore a little bit later how it does it, but this full wave rectifier is capable of using both the positive and the negative half of the wave and transforming them both to be positive. So how does it differ functionally from the half wave rectifier? It uses both halves of the input AC wave and transforms them so that they're both positive. When the load in rectifier 1 experiences current I in the direction shown, which diodes are allowing current? Alright, just found out that my question already had an error in it. I had to move I. It was over here. Now it's over here. And now the question might have a solution. Okay, so the current is coming out of the AC generator at the moment in such a way that it's traveling through the circuit this way. It's going into this node, which means that it's also going into the supply and out of this node. So which diodes are active? Well, if the current's going in this way, this diode won't accept current in that direction. This diode will. So we can get current through this diode. And if current is meant to be coming out of this node, this diode will not accept current in that direction, but this diode will. So the whole circuit flows like this. Through the load, back around, up, down through this diode, down, around, and back up again. Seems like a very complex way of getting around the circuit, but what it ensures is that the current is always flowing down through the load. Because if the current in the source flips direction, what happens is this diode turns off, this diode turns off, this diode turns on, this diode turns on, and what we get is a current flowing this way. Down, around, up, through this one, around, down through the load just like before, back around, up, over, through this other diode, and back around again. So whenever the current through the source reverses, we reverse the diodes that turn on, resulting in a constant direction current through the load. So to answer the question, at the moment, the way the current is drawn, the diodes which are active are D1 and D2. Okay. Both rectifiers are supplied with the following AC power source. Sketch how the voltage across the loads will vary. So this is like a discussion of what the difference between a full wave rectifier and a half wave rectifier is. Without getting into too much detail, basically the half wave rectifier is going to throw away all the negative sides of the wave. Because in the half wave rectifier, whenever the current attempts to go in the counterclockwise direction, nothing happens. It won't get through the diode. So we'll do the half wave rectifier first. The positive end of the wave makes it. The load gets that part of the wave, but it doesn't get the negative part. It does get the next positive part, and not the next negative part. On the other side, though, with the full wave rectifier, it gets the positive part of the wave and the negative part of the wave, which it flips by reversing those diodes which are active. The next negative part of the wave also is accepted, and the next negative part of the wave is also flipped. And so the wave winds up looking like that. Finally, part D. We add a capacitor to rectifier 2. We want to sketch how the voltage across the load will look like with the addition of the capacitor. What the capacitor does is it stores charge. So in these periods where we're not supplying power, we can draw power that we stored in the capacitor. So when the wave is positive and we're allowed to flow, charge can flow through the load and into the capacitor. But when the source is negative and we get a blockage at the diode, we can instead withdraw that energy from the capacitor and flow it through the load again. So the voltage across the load will look very similar to how it did before. But now, whenever the wave starts to fall, instead of going all the way down and following the power source, we drain the capacitor until we get to the next wave. Right. So in this way, we can take an AC wave and smooth it out into something that approximates a DC wave. And that's more or less the process that your wall warts are doing when you plug them in for your digital electronics like your laptop computer or your iPhone. Those big clunky things that you plug into the wall and get warm, they're taking the AC wave in the wall and transforming it into a DC wave using a rectifier with some sort of a smoothing unit.